Have you ever wondered why so many refineries have a flame burning high above them, day and night? From far away, especially at night, it looks like the strangest point in an industrial city. Lit-up towers, giant tanks, pipes crossing everything like suspended streets, steam rising slowly, and that steady flame cutting through the sky. Many people see that scene and have no idea what it means. It is called a flare or flare stack, and it is part of a safety and control system. During pressure relief, startup, shutdown, or operational instability, combustible gases can be sent to that flame and burned in a controlled way, instead of building up where they could create danger. Welcome to Invisible Structures. Today, you are entering one of the most complex industrial cities on the planet, a refinery. The place where dark, uneven crude oil begins a transformation that ends in a car's tank, a truck on the highway, a plane in the sky, the asphalt under tires, and even raw materials that may later become plastic. Because a refinery is not just a gasoline factory. It works with heat, pressure, sensors, valves, flammable gases, and hot liquids to separate, clean, and transform a natural mixture into products that must leave with quality, safety, and precision. That flame high above is only the visible part of control. Behind it is a maze of towers, tanks, pipes, and control rooms working non-stop. Subscribe to Invisible Structures, because the question that begins with fire leads inside a hidden world. How does a dark liquid become gasoline, diesel, asphalt, lubricant, and raw material for modern life? When people think of oil, they almost always imagine fuel. A car at the gas station, a hose filling the tank, maybe a truck crossing the highway. But that image is far too small to explain what a refinery actually does. Oil is in the diesel that powers trucks carrying food to markets, medicine to pharmacies, and products to stores. It is in the jet fuel that moves airplanes. It is in liquefied petroleum gas used in homes and industries. It is in lubricants that protect engines, gears, and machines. It is in the asphalt on the streets. And for many people, here comes the surprise. It is also behind a huge part of the plastic world. Look around. Packaging, car parts, pipes, wires, synthetic fabrics, containers, films, hospital equipment, and everyday objects can begin with raw materials derived from oil. Before they become plastic, these molecules pass through other industries, especially petrochemicals. But the origin of many of them is there, in fractions separated and prepared within the oil chain. This is the first major revelation. A refinery does not exist only to make gasoline. It exists to transform crude oil into a basket of products. And why does oil allow so many paths? Because it is not one single uniform substance. It is a natural mixture of light, medium, and heavy molecules. Some evaporate easily and behave almost like gases. Others have intermediate weight and can move toward liquid fuels. Others are dense, viscous, and difficult to transform. Think of oil as a crowd entering a station. Some people move fast, some move slowly, some carry heavy loads, and some are headed to different destinations. The refinery has to organize that crowd. And not all oil arrives the same way. Lighter crude usually yields more components that are easier to upgrade. Heavier crude demands stronger processes. Oil with more sulfur needs more cleaning, because modern fuels cannot carry impurities in just any amount. Here, an important myth falls apart. Gasoline does not exist ready-made inside crude oil. Diesel is not sitting there either as a perfect liquid waiting to be extracted. What exists is an irregular mixture, full of possibilities. If this idea has already changed the way you look at oil, hit the like button now, because the next step is the first big trick of this city of pipes, using heat to organize chaos. The question is, if oil is such an irregular mixture, what is the first thing a refinery does to start separating all of it? Before entering the most famous tower in the refinery, the oil must go through preparation. It can carry water, salts, and impurities from extraction and transport. It may sound like a detail, but inside a refinery, details become expensive problems. Water and salts, when they enter hot equipment, can speed up corrosion, form deposits, and damage pipes, pumps, heat exchangers, and valves. That is why the refinery begins by trying to protect the refinery itself. After that preparation comes the first major transformation: distillation. The oil is heated until it becomes extremely hot, then sent into an enormous tower, a vertical structure that may look like just another metal cylinder in the middle of the plant, but actually works like a building for molecules. Imagine a building with several floors, but instead of separating people into apartments, it separates families of molecules by temperature. The lightest parts of the oil evaporate more easily. When they enter the tower, they rise higher. The medium parts rise to intermediate regions. The heavy parts, denser and harder to evaporate, remain lower down. And at the bottom of the tower, the heaviest materials of all collect, the ones that must follow other paths inside the refinery. It is a simple but powerful idea. The refinery uses heat to organize chaos. At the top, gases and light fractions may come out, connected to liquefied petroleum gas and other light products. A little lower, streams appear that may move toward naphtha and components used in gasoline. Near the middle, fractions related to kerosene and diesel emerge. In the lower sections, heavy streams come out, which can feed other units, become fuel oil, lubricants, asphalt, or move into conversion processes. But here, there is an important catch. The tower does not deliver finished gasoline. It also does not deliver perfect diesel, finished kerosene, or ready-made plastic. What it does is separate oil into groups. It is like taking a huge mixture and saying, the light ones go here, the medium ones go there, the heavy ones go down. But those groups still need to be treated, cleaned, improved, or blended before they become final products. Think of the tower as industrial sorting. It does not finish the job. It decides the first destination for each part. This is one of the most important points in understanding a refinery. Separation is not enough. Modern gasoline needs performance, volatility, and quality within standards. Diesel has to work in demanding engines and meet quality rules. Aviation fuel must be reliable under extreme conditions, and the fractions that feed petrochemicals need the right characteristics to keep transforming until they become plastics and synthetic materials. So when someone says oil turns into gasoline, it sounds like a simple transformation. But in practice, oil first becomes families of molecules. Then those families pass through a kind of industrial workshop. Now, comment below. Which part of this process has surprised you the most so far? The flare flame, oil hidden inside plastic, or this tower that separates molecules with heat? And write your city and region too, because it is amazing to see where the invisible structure's audience is watching from. The distillation tower is the refinery's first great filter, but it leaves an even bigger question. If it only separates, what happens to the parts that are too heavy, too impure, or not valuable enough to become modern fuel? After the distillation tower, the refinery has already organized the oil into families. The light parts went one way, the medium parts another. The heavy ones stayed lower down, and the densest residues were sent to specific destinations. But separation is still not enough. Now begins one of the most impressive parts of the refinery, the molecular workshop. There, the plant does not just heat oil. It changes the structure of molecules to extract more value from each part of the barrel. Some fractions that leave the tower are too large, too heavy, or not useful enough for the demands of the modern world. Instead of accepting that as the end of the line, the refinery can break those molecules into smaller pieces. That is the basic idea of cracking. The name sounds technical, but the image is simple. Think of a log too large to fit in a furnace. You do not throw the log away. You cut it into smaller pieces that are easier to use. With heavy oil molecules, the logic is similar. Cracking processes can transform difficult fractions into lighter, more valuable components. That is why a refinery tries to use the entire barrel. The heavy part does not have to become only leftover material. Depending on the technology available, it can gain a new destination and enter the production of fuels or other derivatives. And the refinery does not only break molecules, it can also reorganize some of them to improve the quality of certain components, especially those connected to gasoline. It is not enough to have a light fraction. It has to work well in the engine, deliver proper performance, and meet specifications. Think of it as a high-precision industrial kitchen. The tower separated the ingredients, but they are not ready to serve yet. Some need to be cut. Others need to be purified. Others need to be combined in just the right measure. There is also an essential step: cleaning. Oil can carry sulfur and other impurities, and modern fuels cannot leave loaded with just anything. Gasoline, diesel, and kerosene must meet standards for quality, performance, and emissions. That is where processes like hydrotreating come in, helping remove unwanted compounds with hydrogen, catalysts, and controlled conditions. This part does not draw as much attention as a giant tower or a flame in the sky, but it is decisive for the final product. The most important sentence in this act is this: the refinery does not just separate oil, it corrects oil. It corrects molecules that are too heavy. It corrects impurities. It corrects quality. It corrects the destination of fractions that, by themselves, would have less value. What once seemed hard to use can become fuel, raw material, oil, asphalt, or another industrial product. This is where the refinery reveals its industrial intelligence. It does not treat the barrel as one single liquid. It treats the barrel as a set of opportunities. Every stream leaving one unit can become the feed for another. If you are enjoying seeing this plant from the inside, hit the like button Because now everything starts coming together. The flare flame, the distillation tower, cracking, cleaning, and the tanks are not separate pieces. They are organs of the same industrial city. And that city works to answer one final question. After separating, breaking, reorganizing, and cleaning, how do all these components become gasoline, diesel, asphalt, lubricants, and raw materials that actually go out into the world? Now, the refinery reaches the stage where everything must become a real product. After the flame, the preparation, the distillation tower, the cracking, and the cleaning, the components move on to tanks, blending, analysis, and final adjustments. Here, another myth collapses. Gasoline is not a single liquid drawn ready-made from the tower. It is an industrial recipe. Different components are combined to achieve performance, safety, volatility, octane rating, and quality standards. Diesel also has to be adjusted, treated, and tested before it goes out to fuel trucks, buses, farm machines, generators, and a huge share of logistics. None of this is released on improvisation. Laboratories analyze samples. Systems measure properties. Operators monitor tanks, pumps, valves, and transfer lines. Every product must follow specifications because off-spec fuel can cause failures, loss of performance, and problems in engines and equipment. After approval, derivatives begin leaving the refinery. Some travel through pipelines. Others go by trucks, ships, trains, or distribution terminals. The plant does not finish when it separates oil. It finishes when it delivers standardized products to the real world. And then that city of pipes spreads into everyday life. Gasoline goes to cars and motorcycles. Diesel moves trucks carrying food, buses transporting people, tractors in the fields, and machines on construction sites. Jet fuel carries airplanes across the sky. Liquefied petroleum gas reaches homes and industries. Lubricants protect engines and gears. Asphalt appears on streets, avenues, and highways, perhaps one of the most forgotten links between oil and modern life. And plastic enters as one of the strongest revelations in this chain. Many objects that seem to have no connection to a refinery may begin as molecules from oil. Packaging, synthetic fibers, pipes, parts, films, and materials used in cars, hospitals, homes, and factories can be born from inputs that move into the petrochemical industry and continue transforming. That is why a refinery should not be seen only as a fuel factory. It is a structure that takes a dark, irregular liquid that is difficult to use and turns it into different paths: energy, transportation, paving, machine protection, and raw material for other industries. Now, return to the opening image. The flame high above the refinery seemed like just a curious detail on the horizon. But it was the visible sign of an entire city working under control, dealing with pressure, heat, flammable gases, and molecules in motion. Behind that flame are towers that separate, units that break, processes that clean, tanks that store, laboratories that test, and systems that deliver products to almost every corner of modern life. In the end, the oil that entered as a crude liquid may end up in a car's tank, a truck's engine, a plane in the sky, the asphalt under tires, a factory machine, and even at the origin of plastic objects we use without thinking. If you learned something new, subscribe to Invisible Structures to keep seeing the hidden structures behind the modern world. And comment which discovery surprised you the most: the flare flame, the distillation tower, the molecular workshop, asphalt, or the link between oil and plastic.